In this lesson, we will discuss inverse matrices. The inverse of a number, more particularly a fraction, is its reciprocal. So the inverse of 2 over 3 is 3 over 2. Likewise, the inverse of 4 would be 1 over 4. We remember from algebra, the multiplicative inverse states that the product of two inverses is always equal to 1. Also, multiplicative identity property tells us that anytime we multiply a number by 1, the result is just the number that we multiplied by 1. So anytime you multiply a number by 1, you end up with what you started with. Using matrices, the identity matrix is the following matrix. 1, 0, 0, 1. That is the identity matrix. It is the matrix equivalent of the number 1. As you can see here, if we multiply the matrix 2, 3, 4, 5 by the identity matrix, when we apply the steps for multiplying matrices, we will get the following matrix, 2, 3, 4, 5. So the identity matrix is the equivalent of 1. When you multiply a matrix by the identity matrix, your result is the original matrix that you started off with. So given the following matrix, its inverse can be written as follows. 1 over the determinant of that matrix times B2, negative B1, negative A2, A1. What we did there was we took the original matrix and we flipped the element in the top left and bottom right, and then we negated the elements in the bottom left and top right, and the number in the below the 1 is the determinant of the matrix. Notice the absolute value bars that denote the determinant. It should also be remembered that a power of negative 1 denotes the inverse. So 2/3 to the power of negative 1 yields 3 over 2. All right, so in this example, we're going to find the inverse of this matrix. You should start by finding the determinant. The determinant of this matrix would be 2 times 4 minus 4 times negative 3, which gives us a value of 20. So the determinant is the value of the determinant is 20 for this matrix. And then once you find the value of the determinant, you want to then flip the top left element in the top left and bottom right, and then negate the elements in the bottom left and top right. So this is what our inverse would be. The inverse of our given matrix would be 1 over 20 times the matrix 4, 3, negative 4, 2. And we can verify that. As was stated a couple slides ago, any number times its inverse is equal to 1. So if we take the original matrix and multiply it by its inverse, we should get 1. All right, so we have a scalar in front of our second matrix. We have 1 over 20. If we multiply that 1 over 20 to everything inside the matrix, we get 4 over 20, 3 over 20, negative 4 over 20, 2 over 20. And then we multiply. When we multiply two matrices, we take each row of the first matrix and multiply that by each column of the second matrix. When that is all said and done, you should get the following expressions. And then when we simplify those expressions, we get the following. Further simplifying the expressions, you can see now we have the zeros in the bottom left and top right. And then when we simplify the top left and bottom right, we get that identity matrix, which again is the equivalent, matrix equivalent of 1.